All right, so in this last video for this unit, we're going to be talking about some additional probability rules. And really, these aren't so much additional as they are more generalizations of the rules that we've already seen a couple sections ago. And so the first one we're going to talk about is the general addition rule. So this is going to be the rule that we'll use when events are not disjoint. Remember that in order to use the addition rule before, we had to have events that were disjoint, meaning that there was not any overlap. And if there was an overlap, we couldn't use the addition rule. Well, the nice part is the general addition rule works all of the time. And so here's what that rule says. If you want to find the probability of A or B, you have to take the probability of A plus the probability of B, that part we already knew, but then you have to subtract the probability that both A and B happen. Now, before that part, we've always just made sure that that last part was always 0. And so that's what allowed us to use that rule before. But to use this rule in general, we've got to have that additional part where we subtract the overlap. And usually what helps to kind of make this rule make a little bit more sense is to visualize it. And we're going to do that actually using a two-way table in this example. So a survey of college students were asked the questions, are you currently in a relationship, and are you involved in intercollegiate or club sports? They found that 33% were currently in a relationship and 25% were involved in sports. 11% responded yes to both of those questions. So just as a practice and to help us visualize it, let's do something we did in the last section, and let's make a two-way table for this information. So we'll make our 3 columns and our 3 rows. And we have 2 questions, whether they were in a relationship or not. So I'm going to call that relationship and relationship complement. And again, remember, a relationship complement just means not in a relationship. And then also whether they were involved in sports or not. So I'm going to call that sports and sports complement. And then obviously we have totals for both the columns and the rows. Okay, so the survey found that 33% were currently in a relationship, so our total for relationships is 33. 25% were involved in sports, so 25% was our total for sports. And then it tells us that 11% responded yes to both. Now, if you recall a previous example, remember that when dealing with percents, it's our job to remember that they have to add up to be 100. So I'm going to go ahead and put that as our overall total for the table. So then filling in the rest of the information, we'll put 14 here, 22, and it doesn't matter which order you fill these in. Remember, an easy way to check yourself is with the last part, the very center square, and that does end up working out to be 53 in both directions, so it looks like we're good to go. So for the first probability, what is the probability that a student is not in a relationship? Well, that they are not in a relationship, that would be that they are in a relationship complement. In other words, that 67% out of 100. And again, if you want to put that as a decimal, that would just be 0.67. Now let's go ahead and use that new rule for the general addition rule. So we know what is the probability that they are in a relationship or that they are in athletics or sports. So relationship or sports, what that should be equal to is the probability that they're in a relationship plus the probability that they're involved in sports. But then here's where this rule is kind of useful to visualize. So let's look at what we're adding together so far. We're adding together the probability that they're in a relationship, so this part, plus the probability that they're involved in sports, which is this part. Notice that there's an overlap, and that overlap is right here. And that's where the probability that they are involved in a relationship and in sports is being counted twice. That's why we're subtracting it, is we want to only count it once. Okay, so let's go ahead and put in our numbers. So the probability that they are in a relationship is the 25% that we had already found. The probability that they're involved in sports, we already know, is 33. And then we're going to subtract off the probability that they're in a relationship and involved in sports, which is the 11. And if we combine those together, 25 plus 33 is 58. Minus 11 is 47%. So there's a 47%, or as a decimal, a 0.47 chance that they are involved in a relationship or involved in athletics. Okay, So let's next talk about conditional probability. This is another type of probability that we actually haven't seen yet. So this one is a little bit new. So a conditional probability is the probability that an event happens given that another event has already happened. And our formula for conditional probability is the probability of A given B. So again, when you see this bar, that just is read as given. And that's going to be equal to the probability of A and B divided by the probability of B. Now, I suppose there is another formula if you wanted to switch around B and A to write that out explicitly. The probability of B given A is still the probability of A and B, but this time divided by the probability of A. So depending on how you want to write it, either one of those is an acceptable way to write conditional probability. So let's use that information to answer some of these questions. So first off, for part A, what is the probability that a student is not involved in sports? So the probability of sports complement. We'll go back up to our table that we made for sports complement. Getting a little messy. Let me erase some of this stuff real quick. But sports complement is going to end up being this part right here. So that's going to be the 75% of students who are not involved in sports. Or again, as a decimal, 0.75. So then for B, what is the probability that a student is in a relationship given that they are not involved in sports? Okay, let's write this out with notation and then see how the formula can be helpful. So we want to know what is the probability that they are in a relationship, so the probability of R, given that they are not involved in sports, so sports complement. Okay, so using our rule, we're going to say that that's the same as taking the probability that they're in a relationship and that they are not involved in sports, so sports complement, divided by the probability that they are not involved in sports, so again, sports complement. Well, we already have one of those probabilities. We already know the probability of sports complement we found in part A is 0.75. So the part that we're missing is the probability that they're involved in a relationship and not sports. So relationship and not sports, that's going to be this 22% right here. So I'll put that as a decimal 0.22. So then all we have left to do is go ahead and divide those. So 0.22 divided by 0.75 is going to be 0.293 repeating. So there's about a 29% chance that they're in a relationship given that they're not involved in some kind of sports. Now, while the rule is helpful, and you see how the formula can be very helpful with just kind of grinding it out, there's an easier way to look at things. And so let's look at that with part C. So if we want to define the probability that a student is involved in sports, given that they are in a relationship. So let's find the probability of S given R. Well, when it says given that they're in a relationship, so given R, what that really means is that we are only going to look at this column for R, which means instead of the total being out of 100, now your total is going to be out of 33. And we want to know what is the probability that they are involved in sports. Well, again, looking at only that column, there was 11% that were involved in sports that had a relationship. And so if you take 11 divided by 33, that ends up being 0.3 repeating. So about 33% of students are involved in sports given that they were in a relationship. So you can use either the rule to figure out conditional probabilities, or you can just use the table, understanding that whatever part is given to you is the only part of the table that you are using. Okay, the last thing we're going to talk about is the general multiplication rule. And in order to do that, we need to talk about how we can tell if events are independent or not. Now, how can you tell if two events are independent? Well, one way that's not always the most reliable is just logic. You can just think to yourself, does one event depend on another event happening? And sometimes you can figure out if two events are independent that way. But probably the more reliable way using probability is to use conditional probabilities. Is the probability that A given B happens the same as just the probability that A happens? And if so, then they are independent. If not, then obviously they're not independent. So let's use that method using probabilities to determine whether or not some events are related to each other. So based on the information from our previous examples, are the events in a relationship and not involved in sports independent? Okay, so we've got our two different variables we're looking at. So we're looking at in a relationship and we're looking at sports complement. So let's go ahead and see, is the probability that someone is in a relationship, given that they're not involved in sports, the same as the probability that they're in a relationship? Well, let's find those probabilities. The good news is the probability of being in a relationship, given that they are not involved in sports, is something we've already found. We found that that was 0.293 repeating. So we want to know, is this equal to the probability that they're in a relationship? Well, if we go back, we haven't found that yet, but we could just look at our table. The probability that they're in a relationship is 33%. And pretty clearly, 0.293 is not equal to 33. So these events are not independent of each other. So they are in some way dependent on one another. Let's check another one. So are the events involved in sports, so that would be S, and in a relationship, which is R, are these independent of each other? So what we want to find is the probability of S given R the same as just the probability of S? Well, again, good news. That probability of S given R is something we found right here in part C. We found that to be 0.3 repeating. So really we just need to find what is the probability that they're involved in sports. So probability of S, and again, we'll go back to our table. Probability of S is this 25%. So is 0.3 equal to 0.25? And pretty clearly they are not. So once again, these events are not independent. And again, in order for them to be independent, they have to be the exact same probability for both. Okay, so that leads us to our general multiplication rule. So for events that are dependent events, we're going to take the probability of A and B to be the probability of A multiplied by the probability of B given A. Remember before that this was just probability of A multiplied by probability of B, but events have to be independent for that to be the case. Or we could also write this another way as probability of A and B is the probability of B multiplied by the probability of A given B, depending on which events you have more information on. So you can either use A or B, and then your conditional probability from there. Okay, so what is the probability then? Let's look at an example of rolling a 3 on a 6-sided die and flipping a coin and getting heads. So let's make the rolling a 3 one event. So this is the probability of a 3, and flipping a coin and getting heads is our second event. So that would be H. So then for our rule, we're going to say, what is the probability of rolling a 3 and getting heads? Well, that would be the probability of rolling a 3 multiplied by the probability of getting heads, given that we rolled a 3. Well, the probability that we roll a 3 on a 6-sided dice is just 1 out of 6. Here's where our conditional probability actually ends up just being equal. And in fact, if you think about it, these are independent events because of the fact that getting heads and flipping and rolling your dice are not related to each other at all. And so the probability of getting heads, given that you rolled a 3, is really just the same as the probability that you get heads, and that's just 1 out of 2. So multiplying those together, our probability ends up being 1 out of 12. And again, if you want to put that as a decimal, that would be 0.083 repeating. Okay, we've just got one last example to look at. This really does not have much to do with what we've looked at so far in the notes today. It's just a good kind of overall example to tie everything in together. So the first trimester screen is a non-invasive test that's given during the first trimester of pregnancy to determine if there's any specific chromosomal abnormalities in the fetus. So according to a study published in the New England Journal of Medicine in November 2005, approximately 5% of normal pregnancies will receive a false positive result. So if we think about among 100 women with normal pregnancies, what is the probability that we get at least one false positive? Okay, so let's think about what this means. We want the probability that the number of false positives X would be greater than or equal to 1. Now, I guess one way you could think about that is, what is the probability of one false positive plus what is the probability of two false positives, all the way up to the probability of 100 false positives. But that's 100 probabilities that we're going to have to find. And I don't know about you, but that doesn't sound like very much fun. So let's think about it another way. Rather than looking at all of the probabilities that they get at least one false positive, what if we took 1 minus the probability that there are no false positives? And really by doing that, kind of using the complement rule, we should be able to find the probability of getting at least one false positive. Okay, so let's figure out how to find this probability of no false positives. Well, the probability of one false positive is 5%, so no false positives would be 95% for the first pregnancy. But then we don't want just one of our pregnancies to be not false positive, but we need for all 100. In other words, 0.95 multiplied by itself 100 times. An easy way to represent that is using exponents. That's 0.95 to the 100th power. And now we just have to do that computation using a calculator. So if we take 1 minus 0.95 to the power 100, that ends up being 0.9941. In other words, there's about a 99% chance that in a group of 100 women that we would have at least one false positive. In fact, we would expect about 5% of those. So we would expect about 5 women to test false positive, but the probability that we get at least one is almost 100%. All right, guys, that's all I've got for us in this section. Until next time, have a great rest of your day.